In the previous video, we just solved a lot of exercises, close to like 4 or 5, that dealt with working with decimal. But in this instance, most of the exercises under exponential equations that we're going to be dealing with will take us into simple equation or even quadratic equation. So the third set that we are working on is question number 10 to number 14. We have 5 raised to power a minus 1 equals to 0.2, and 2 to the power of 3a plus 1 equals 1, and 4 to the power of a plus 1 equals to a to the power of a. And number 13, 3 times 9 to the power of 1 plus b equals to 27 minus b. And number 14 would definitely take us into quadratic equation. So how do we solve this? If you are confident or you want to give it a try, you can pause the video and start working on it, and then you join us on the other side. But if you want to go along, you can still participate in that discussion. So let's go ahead and start with question number 10. Okay, so we have 5 to the power of a minus 1. How do we approach this? You look on the right hand side here, we have 0.2. The question is how many number after the decimal is only 1. So we can turn it into a fraction where we have 2 over 10. So we can rewrite this one as 5 to the power of a minus 1 equals to 2 over 10, because 2 over 10 is equals to same thing as 0.2. Our goal is to give it a semblance of something we can work with, because if you look at it, if you turn it to fraction, 2 will go in 10 5 times. So automatically our goal is that this will be 1 and this will be 5. We are going to have 1 over 5. So we can go from there and now continue with our equation. So we have 5a minus 1 equals to 1 over 5. Remember the rule where we have c to the power of minus a, we have 1 over c to the power of a. So in this instance, we have 5 to the power of a minus 1 equals to 5 to the power of minus 1. So with that, we can take care of the base number, and the base number is 5. So we'll say divide both sides by 5. So we divide both sides by 5. So what happens in that instance? We can rewrite before we solve it further. So we have 5a to the power of minus 1 equals to 5 into minus 1. And you see what happens? The 5 will cancel out. In that instance, we are left with a minus 1 equals to minus 1. For us to solve for the value of variable a, we need to bring to mind our simple equation. We can add 1 to both sides. So add 1 to both sides. And you see what happens when we do that. So we're going to have a minus 1 plus 1 and minus 1 and then plus 1. So we have a is equals to 0. So the value of a equals to 0. And like we said earlier, please always self-check. So if we self-check this one, we have a minus 1 equals to, we don't know. So we have 5 into 0 minus 1. And that is a 5 minus 1, and that's 1 over 5. And see what we have here? Exactly the same thing. So that one is correct. So we move on now to question number 11. So let's go to question 11. What do we have? We have 2 to the power of 3a plus 1 equals to 1. Now, how do we approach this? Remember the last question we solved when we have something on the left hand side not equal to what is on the right hand side. We remember the index, anything to the power of 0 equals 1. So will you agree with me if I come in here and say 2 to the power of 3a plus 1 equals to 2 to the power of 0. Now we can set into motion to divide both sides by 2 here. So we divide both sides by 2. So when we divide both sides by 2, see what happens here. So we have 2, 3a plus 1 equals to 2 to the power of 0. And this is what happens here. So this will cancel out, and we are left with a 3a plus 1 equals to 0. For us to determine the value of variable a, we can subtract 1 from both sides. So we can say subtract 1 from both sides. So that way we'll be able to have 3a plus 1 minus 1 and 0 minus 1. So this will become 3a minus 1, because plus 1 minus 1 will be 0. You have 1 and you hold 1. So if you pay 1 that you have, you are left with nothing. So that is why we have plus 1 minus 1 equals to 0. And please, if you are still struggling with this topic, go down below this video to study sine integers. We have full video that will help you to understand sine integers exercises from A to Z. So now we come back here to determine the value of a. We are going to divide both sides by 3. So divide both sides by 3. So this will be 3a over 3 and minus 1 over 3. And this will cancel out. We are left with a is equals to minus 1 over 3. And that is the value of a. So please don't forget, always self-check. That's our goal. We want to always self-check. Now we move on now to question number 12. And what do we have? We have 4 into a plus 1 is equals to 8 to the power of a. Now this looks different than what you have seen before, and that is why we have these revision exercises. Look at what is on the left hand side and what is on the right hand side. How do we approach a problem like this? We have 4 on the left hand side and we have 8 on the right hand side. How do we solve this? We want to look for the factors. So let's start with the factors. So it will help us. 2 times 2 to the power of a plus 1, and this will be 2 times 2 times 2 to the power of a. So now you can see we have been able to even both sides. We have 2 in 2 places on the left hand side and 2 in 3 places on the right hand side. So what do we do next? Remember, they are all to the power of 1 each. And if we follow CA times CB is equals to C into A plus B. The same thing we are going to do here. So this will be 1 plus 1 to the power of A plus 1. And this will be 2 into 1 plus 1 plus 1 into the power of A. Now you can see how we are breaking them down stepwisely. And this will become 2 to the power of 2 into A plus 1. And this will be 2 to the power of 3 into the power of a. Now, what do we do next? We're going to deal with the parentheses. So our goal is to work with the parentheses. And how do we do that? We have 2 into 2a plus 2. Because these 2 will multiply this a, and these 2 will multiply this one. So 2 times a. So 2 times a will be equals to 2. And 2 times 1 will be equals to 2. So we have 2a plus 2. And that is how we have this value here. And the same thing here, we are going to have 3 times a. And that will give us 3a. So 2 to the power of 3a. Now we have that, you can see the same base value. So what do we do with the same base value based on your experience to date? We divide both sides by 2. So divide both sides by 2. So we divide by 2, and let me rewrite it. So we have 2, 2a plus 2 is equals to 2 into 3a. And see what happens now? This will cancel out. And we are left with a 2a plus 2 is equals to 3a. We'll do two things very quickly here to solve the problem. We are going to collect the like terms. So our goal is first to collect the like terms, whereby we have 2a and 3a on one side, and we're able to, so this is what we are going to achieve. We're going to have 3a minus 2a equals to 2. So that is what we are going to have. And how do we set that in motion following the algebraic principle? We are going to start with a collect like terms. So let's collect like terms. So how do we collect the like terms now? We are going to move 2a to be on one side, or we can say add 2a to both sides. Oh, no, subtract 2a from both sides. So subtract 2a from both sides. So here we have 2a minus 2a plus 2 and 3a minus 2a. So this will become 2 equals to a. So this, when we subtract this one, it will become 0, and we are left with positive 2, and 3a minus 2a will be a equals to 2. So in this instance, we have a equals to 2. And don't forget, you want to self-check to get the correct answer, that what we did is correct. So I can quickly do that here. So a plus 1 and then 8a. So let's solve it. We have 4 into 2 plus 1, and that is 8 into 3. I mean 8 into 2. So we have 2, 4 to the power of 3. And that will be 8 to the power of 2 here. That's how we solve that. So 4 times 4 times 4, and then 8 times 8, 64, 64. And we move on from there. So we have solved question number 12. We can now move on to question number 13. So let's go to question number 13. Question number 13 is 3 times 9 into 1 plus b. And that is equals to 27 into minus b. And this is what I want to assure you up front. When you see questions like this, don't panic. Be calm and apply the law of indices, or the exponential law. So in this instance, we look at good thing. Look at 3, 9, 27. There's much more close proximity there. So we can break it down, and this will become 3 and 3 into 1 plus b. And this is to the power of 1 each. And for here, we have 3 times 3, 9 times 3, 27 to the power of minus b. And this is to the power of 1 as well. Remember our rule, b is equals to ca plus b. So in this instance, we'll keep this one separately for now, and let's work with this one. So 1 plus 1, and then 1 plus b. And this one will be 3 into 1 plus 1 plus 1 equals to minus b. To solve further, let's keep this one for now, and this will be 3 into the power of 2, 1 plus b. And this will be 3 into the power of 3, and we have minus b. Now, we can remove the parentheses here. When we remove the parentheses, it's going to change the whole setup. So we have 3 times 3 into 2 plus 2b. So we have 2 plus 2b. That is what we are going to get. And this will be 3 into minus 3b, because 3 times minus b is minus 3b. And 2 into 1 plus b will be 2 times 1 and 2 times b. And we have this value. So this will now become 3 into 1 plus 2 plus 2b equals to 3 into 3 minus 3b. Oh, 1 second. So this will be minus 3b. So for us to solve this further now, you see what is on the left hand side. We have a common value in 3. So we can say divide both sides by 3. So with that, we can come in here and write them appropriately. 1 plus 2. Oh, I can solve this one. This one is solvable here. This will be 3 plus 2b. And that is what we are going to have, equals to 3 into minus 3b. And we can come back here and this will cancel out. So we have 3 plus 2b is equals to minus 3b. So for us to solve it, we can subtract 2b from both sides. And that helps us to fast track everything. And that's collecting the like term. So subtract 2b from both sides. And when we do that, we're going to be left with a 3, 2b minus 2b, and then minus 3b minus 2b. So this will be 3 equals to minus 5b. So that is what we are going to have. And for us to be able to solve this further, we can now move forward and said divide both sides by minus 5. And when we do that, we're going to have 3 over minus 5 and then minus 5b over minus 5. So let's go. This will cancel out and this will cancel out. So therefore b is equals to minus 3 over 5. And here you have your answer. Minus 3 over 5 is the correct answer. Please don't forget, just to be able to build your confidence, always self-check. So we have one more to go. Let's go to the final one. And I think this would be a nice experience for all of you. Some of the questions that you come across from question number 10 to question number 14 are usually questions you see on exam like IGSCE or GCE, SSCE, or even a number of a GED or SAT or ACT. This is where you see this question. I want to break it down in such a way that you will understand it so that when you see something closer to this, you'll be able to solve them. So let's go to the last one. This is a 2 to the power of 2x minus 3 into the power of 2x and plus 2 equals to 0. You can use the link below if you want to know about powers, roots, and exponential equation in detail, because some of these exercises are included in the tutorial that we have dealt with for those of you that have participated in all those online classes. But I just want to make sure you use this skill set to prepare for your ACT and for your SAT exam, because I know some questions like this do come up and I want you to be able to get them correctly. So let's break this one down. How do we approach this? You can see 2 to 2x here. So what we are saying is that we have x and then we have x, and then that is 2. And then we have 3 into 2 to the power of x plus 2 equals to 0. As you can see from here, there's something that is common here. We have 2x. So these two can be rewritten. So these 2 to 2x can be rewritten as 2x to the power of 2. Remember, 2 times x is equals to 2x. Associative and commutative law. So we can apply it here. So in that instance, I'm going to rewrite this as 2 to the power of x and say 2 here. Minus 3 into 2x plus 2 equals to 0. With this in mind, you can see something that is clear. This is a 2 to the power of x, 2 to the power of x. So instead of us repeating it over and over, we can just save our time and come back to it later. I want to say let 2 to the power of x be a. So that way we don't have to keep repeating it. So we have a squared minus 3a plus 2 equals to 0. Does it look familiar? Yeah, that is what we are talking about. This is a typical example of how an exponential equation become a quadratic equation. And how do we solve this further? We can just apply factor method to make life easier. I'm going to look at the coefficient here and the coefficient here. 1 times 2, that is 2. I'll look for what two numbers can we add together that will give us 3a. So I have a squared minus a, and then minus 2a, and then plus 2 equals to 0. So I have that, and I can factor what is on the left and what is on the right. So I look at a, open the bracket, and then also on this side, minus 2, and open the bracket, equals to 0. So what do I multiply by a? That will give me a squared, and that will be a. And what do I multiply by a? That will give me a. That will be 1. So we have a minus 1. And we do the same thing exactly here. What do I multiply by 2? That will give me 2a. That will be a. And what do I multiply by 2? That will give me 2. And that is 1. So we have a minus 1 here. So you notice minus times minus will give us positive. It will give us positive, and 2 times a. And we can take one of these. See the similarity here and here. So we take a minus 2, that is this and this. And then we take one of these, a minus 1 equals to 0. That is how we start working through. So we have a minus 2 equals to 0, and a equals to 2. That is our first a. The second here will be a minus 1 equals to 0, and a is equals to 1. Now, let's just go from here. Remember, our 2 to the power of x was represented as a. So we'll bring it back here. 2 to the power of x equals to 2. 2 to the power of 1. And here, we are going to have 2 to the power of x equals to 1. How do we solve this? So let's bring them here. So 2 to the power of x equals 2 to the power of 1. If we divide, x will be equals to 1. So we have x to 1. And then we come back here. 2 to the power of x equals 1. 2 to the power of x equals to 2 to the power of 0. And x equals to 0. Remember our index rule. Anything to the power of 0 equals 1. And our final answer will be x will be 0 or 1. So therefore, x is equals to 0 or 1. And that will be our final answer. So please, I will encourage you to take time to go over these exercises one more time, just to be able to practice the solution until you are very comfortable with all of them, that you can see exponential equation as piece of cake. And you can see we're just playing with number just only at an advanced level. And that is the fun I want to share with you. The moment you know this stuff, you can't forget them. You'll always remember, but please practice and practice a lot of exercises. So when you see questions like this on the exam, you'll be able to scale them very easily. So question number 10, and you can see question number 11. You can pause them at any point in time, so that way you can revise everything to make sure you understand. And don't forget the rule of thumb that we've been emphasizing. Please, after you determine the final solution, make the effort to self-check. It is very important that you make the effort to self-check. I know I tried to cut this video short. Unfortunately, this content cannot be split because I want to pass it on to my students for the revision classes preparing for SAT and ACT. and I want you guys to benefit from it. So I'll be posting this one on YouTube, and please, if you are willing to learn more about powers and roots and also exponential equation, you can enroll in the foundational classes, or you can join the Math Elite membership program. The link is below this video as well, and I'll see you in class. So thank you very much for joining the revision class for today, and I'll see you guys I think in 2 weeks for another revision class. Enjoy the rest of your day. Enjoy your weekend.
If you find values in these math videos, please subscribe to be notified when the latest videos are uploaded every week. Also, check out the links below this video for more comprehensive math video tutorials to help you with your math studies, or in case you are preparing for your math tests, or any of the math exam listed below. Our goal at Practical Math Academy is to make sure you understand all the math topics you will be evaluated on. Also, see you succeed by practicing sufficient math exercises that will boost your confidence when taking any of these math tests or exams. Our promise is to assure you that when you study these math video tutorials and practice along, it will boost your confidence, help you gain a better understanding of the math concepts discussed, and when you see these questions on the test, you are more confident to apply the skills, and you will come out in flying colors. One of the best ways to consistently benefit is when you subscribe to this channel. You will be notified every week when latest videos are posted. There are additional benefits. We also post solved math questions from weekend revision classes, and you do not want to miss these solutions to past math questions. This gives you insight into how some of these math questions are asked, and how best to answer them under the limited time allowed by the math examiner. Links to comprehensive math video courses are listed below. Please check them out and learn more on how you can take your math understanding to the next level. You can also take our math survey to develop a solid foundation in your understanding of math. Thank you very much for stopping by today.